Perfect. Thank you so much. Thanks for the introduction. My name is Maha and I'm from Aberdeen Science Centre. I work as the STEM Learning Schools Lead at the Science Centre. So what I'll do is I'll just start sharing my screen here so that we can start with it. So today's session is going to be about kitchen chemistry. So we'll be looking at different items which you find in your kitchen, how you can turn them into science investigations. So our science centre is undergoing a redevelopment at the moment, which is involving having a different floor. So we will be having 2 floors, everything will be brand new, and we'll be having new exhibits, everything over there. We will be interactive as well. So Aberdeen Science Centre has been one of the pioneers for the interactive science exhibits in UK, and we were the pioneers, or the first ones, to be the Science and Discovery Centre here in Scotland. We also are having this multi-million project to just boost us for those exhibits we are having. We will be opening sometime soon, so the construction work are back up and running. So we are hoping to open, so please keep an eye on our website and social media to see the updates about the reopening. Throughout the lockdown and also during the school holidays, we have been offering some digital sessions. So make sure if you haven't watched them yet, do go and watch them. It's on our social media. So try those experiments. They are all accessible, and they're just using chemicals and things which you can easily find in your home. And so I'm sure you'll be able to do those investigations in your own home. So please do go and try them. If you try any of those experiments, make sure you share your pictures and videos because you have a chance to win a STEM passport that gives you access to go to the new Science Centre for free over a year. So make sure you do that as well. So talking about science, we think the science is quite complex. So it's basically a study of nature, but we can simplify it, saying by looking at things which are around us. So observing things which are all around us, doing some experiments, asking loads of questions, recording them by taking pictures, photographs, videos, writing down some things about science which we find around us, making some predictions, guessing what would happen, because humans by nature are curious. We are always wondering how things work. Einstein was curious, and he was able to look at the apple which fell down from the tree onto the ground and was able to form his theory of gravity. So if we keep an open eye, we will surely see that science is all around us, and we can see science in our food we eat, in our body. The technology we are using these days involves STEM, or science, technology, engineering, maths. So there is science or STEM everywhere, wherever we see. So this is a very famous quote by an English chemist, Rosalind Franklin. And so it says science and everyday life cannot be separated. So they do go hand in hand. And so that's what we are trying to promote today as well. So, and also as a science center. So we are trying to get that idea out that we can do science or look at science even during our everyday life. So today we are going to look at exploring some items which we find in our household, and we will be focusing on kitchen today. So these are different types of items you would be able to see in your own kitchen, and we will be using some of those items today to do some science investigation. So I'll be demonstrating some of those in some time, and also we will be looking at the science behind it, how the science works using those simple chemicals or items in the kitchen. So the Scottish Curriculum for Excellence also has elements of chemistry or properties in the curriculum. So the topic it comes under is called materials, and it's involving simple things, which is like dissolving solids. So even dissolving sugar in water is a science investigation. So you can do simple experiments using that, exploring a property of different materials. So how hard a material is, how soft it is. So those kind of different properties, pH, and other like density, which I'll be showing in a minute. Those are the different properties which you can easily do some investigations with your children at home. So their curriculum for excellence is mostly based on that, and you can try those activities with your kids at home. So coming to the main demonstration part, which is we will be doing 3 different demonstrations today, and I'll be asking loads of questions. So make sure you are popping your answers in on the chat box, or if you have a pencil and paper, just write it down. But as we go along, I'll be also revealing the answers, so you will be able to check your understanding, see if you guessed it right or wrong, and do ask questions if you have any in the chat box as well as I do that. So what I'm going to do is I'm going to stop the screen share, and I'll bring my exciting new chemicals, which I can find, which you can find in your kitchen. So the first one I have here are very simple chemicals. So this experiment involves some liquids and some solids. So as you can see, this is a liquid. So I've colored it. So this is actually water with some food coloring in it. This one, can anyone guess what this could be? This is some oil. So this is just some oil which we use for cooking. And I also have some solids. So I have a coin, a penny, and a toothpick here, which we will be going to test. So what we are going to do with this activity is we are going to test a property called density. So has anyone heard about density before? Oh, that's all right. I'm here to tell you all about density. So density is how compactly atoms are packed inside a substance. So atoms are the tiniest particles which everything is made of. So the table, we are made of atoms, we have air is made of different atoms. So these are the tiny particles which everything is made of. So how compactly they are packed tells how dense a chemical or a substance is. So more dense a substance, it will sink, and if it is less dense, it will float. So let's try these and see which chemicals or which items will sink and which will float. So I have a measuring cylinder here. You can use a bottle or anything you find in your kitchen, so maybe even a glass if you want to do a tiny version of this. So what I'm going to do is I'm going to pour the water in the measuring cylinder. So as you can see, the water has filled up the measuring cylinder. So it's at the bottom just now. Now we will add some oil to it. So do you want to guess and tell me where would the oil end up? So pop it in the chat box. See if you are right in guessing where the oil will end up. Would it go below the water or would it end up above the water? Okay, I will go ahead and add the oil. Oh, someone's saying on top. Let's see if they're right. Okay. Ooh, I think the guess is going to be right. So as you can see, the water is still on the bottom and the oil goes on top. So what does that tell us? It tells that oil is less dense than water, so it's floating on top of water, and water is less dense than oil, so it's below the oil. So what about a penny? So these are different liquids we have in our measuring cylinder. So there's oil and water, but solids also have density. So they also show the property of density. So I'm going to drop this penny in the measuring cylinder. So what do you think? Where would this end up? So pop in the chat box to tell me, what do you think where this penny will end up? Would it float? Would it sink? Would it go in between the oil and water? What do you think? Let's try and see where it ends up. So I'm going to drop it. Ooh. So the penny goes right to the bottom. So it did sink. Well done. So Suzanne has said right. So it does sink right to the bottom. So it goes right to the bottom of water. What about a wooden toothpick? So I have a wooden toothpick here. What do you think? Where would it end up? Right to the bottom, on top of oil, or in between? Where do you think? Pop it in the chat box and tell me. Guess. It's okay if you are right or wrong, at least you will know. Okay, I'm going to try and put it. Okay, so it's right on top. So yes, it is floating on top of the oil. So what does this tell us? So it tells us that the coin is the most dense of everything which is there in this measuring cylinder. So it goes right to the bottom, so it sinks down right to the bottom. Whereas the matchstick floats on top, so it's right on top, so it's the least dense. But am I right to say that? Is the matchstick the least dense of everything which is in this measuring cylinder? Can you guess? There is something else in this measuring cylinder which is the least dense. What do you think it is? You can't see it. Can you guess what it is? That's all around us, but we can't see it. Well, I'll tell you, that's all right. It is the air. So the air on top is the least dense of everything which is there in this measuring cylinder. So using this just simple activity with some water, oil, you can talk about density, and you can talk, even when you're making a salad dressing, when you're trying to mix oil and vinegar, you will see that it would separate out. So you can even try that when you are making a salad dressing. So you can talk about science even when you're cooking. So density is a property which physicists also looks into when they are studying floating and sinking, or even engineers when they are designing aeroplanes, air balloons, or boats. They are trying to look into the density of different materials which will float on water. So they do look into those when they are designing the boats and everything. So density can be used even for the weather prediction. So weather forecasters use density of air to predict what the weather would be depending on how much density is in the air. So these are the small different things you can talk to them about, and also get them involved to do these activities. So I'll put these away and move over to our next activity. Sorry, I'll be popping out of the screen just to grab a few of my chemicals, which I have just set up over the other side. So this next experiment is about pH. So has anyone heard about pH before? So pH is actually a property of a chemical. Imagine it's like a scale. So if the pH of a chemical is more towards 0 or less than 7, it's an acid. And if it is more towards 14, it's an alkali. And if a chemical is somewhere right in the middle, and that is 7, it's neutral. So these are the different properties you can find for different chemicals. So acids, neutral, and alkali. If you are not familiar with these terms, I'll give you a good example. So acids, lemons, have you heard of lemons? Or oranges, any citric fruit. So all citrus fruits have something called citric acid, so it makes them acidic. Bleach, washing powder, bicarbonate of soda, which we use for baking. Yeah, lime, orange, and lemon, I can see some answers there. So bicarbonate of soda, bleach, and washing powder are examples of an alkali. So you find these items in your kitchen for sure. So you can do some science investigations using those. But what about neutral? I'm sure you would have heard something which is neutral, has pH 7. We drink it every day. Can anyone guess what it is? Well, it's water. So water is neutral, so it's right in the middle. It's neither an acid nor an alkali. So I have these 3 different glasses with those different chemicals, but they all look the same, isn't it? So what do you think? Which one is which? How can we find that out? So to find that out, I have done something. So I have this red cabbage juice, sorry, the red cabbage juice is here, the red cabbage is here. So I've chopped the red cabbage, added some boiling water, left it to cool down, strained it, and I have this juice. So red cabbage juice is like an indicator. So I'm sure you would have heard about the term indicator before. Have you heard about the term indicator before? Well, yes, in the car, isn't it? So the indicator lights in a car tells you where the car is going. Is it turning right? Is it turning left? Or is it about to stop? So the indicator in a car tells you what the car is going to do. So the same way goes with the red cabbage juice. So the red cabbage juice tells you what chemical it is. Is it an acid, an alkali, or neutral? So depending on the color we get, we can decide and tell what these chemicals are. But why does the red cabbage juice turns into these different colors? Well, red cabbage has something called anthocyanin. So it's a pigment which you will be able to find in a plant, or even the fruits, the red, pink, and the purple color you see in your fruits and vegetables are because of the anthocyanin pigment we have. So when the pigment comes in contact with different chemicals, it changes into different colors. So we will test and see what is what. So I'll try to add some of the red cabbages, just pour it. Ooh, I see a nice blue color. Can you all see the nice blue color? And I will add, ooh, this is nice and bright pink color. What about the last one? What color do you think would come up for the last one? That's a purple, isn't it? So we have all these different colors here. So now we can tell which is which is an acid, which is an alkali, and which is neutral. So if we compare this, so something which is close to 0 has more like red or pinkish color. So something like this. So this would be an acid. So I am sure I added vinegar, which is also an acid, in one of these glasses. So I'm sure now that this is vinegar, because vinegar is an acid. What about this greenish, nice greenish blue color? Well, that sits somewhere close to the number 12. So it seems like this one is an alkali. So it's more towards the other side of the pH scale. So, and this would be the bicarbonate of soda, the powder I dissolved in some water. So this, I can tell now that this is the bicarbonate solution. What about this one? Well, this is close to the purple color we can find in the middle. So this would be a neutral solution, and we talked about neutral solution earlier. Can anyone guess what this would be then? Something we drink every day? This is water. So yes, the water, which was neutral, shows this purple color, and it is the neutral solution. So acids and alkali, they both are on the opposite side of a pH scale. So they are completely opposite to each other. So when you mix an acid and alkali, and in this case, vinegar and bicarbonate together, they don't like each other. They tend to fight and make a chemical reaction. So when they are doing this chemical reaction, they also release some kind of gas. Can anyone guess what that gas could be? Well, just to give you a clue, it's the same gas which we breathe out. Any guesses? Well, it's carbon dioxide. So when you mix vinegar and bicarbonate, it reacts to release carbon dioxide, and the chemical reaction is called neutralization reaction. So remember, we talked about neutral. So both acids and alkali, when they mix together, they become neutral. So they will make a neutral solution. So that's why it's called a neutralization reaction. So what we are going to do is we are going to mix these together and see what we can observe. So there goes the vinegar, and here is. So as I've mixed these together, I could hear something. I can hear the fizz, and I can also see some bubbles in the measuring tube. So these bubbles are actually the carbon dioxide bubbles which have been released from the chemical reaction. So carbon dioxide was released in the neutralization, and you can also see the color is slightly gone just closer to the lighter pink or the purplish shade. So it has neutralized to form some sort of a neutral solution. So this was our experiment with just some bicarbonate of soda, which I'm sure you would have used for baking cakes, and vinegar. So when you mix those together, you can easily do some science investigation. And the other thing you need would be a red cabbage. And remember, you have to eat your rainbows. So red cabbage is a very good addition to your salads or coleslaw. So make sure you include red cabbage in your diet as well. So when you do that, try this experiment with the red cabbage juice. So just extending over to that experiment, we will see what else can we do with the vinegar and bicarb. So I'm back with some more vinegar and bicarbonate of soda. So I have vinegar in this liquid beaker, in the beaker. So it's a liquid. So what do you think? What was vinegar? Can anyone guess what was vinegar? Was it an acid? Was it an alkali? Any guesses? Well, vinegar was an acid, so it is more towards the pH close to 0. It has around pH of 2. So I'll add the vinegar in a cup. So I have a cup. Just use a normal cup you can find in your kitchen. And I have a glove here. So what I'm going to do is the bicarbonate of soda. So this is the powder I'm using. So I'm going to put some bicarbonate of soda into this glove here. And we are going to test something. So I'm going to put this glove around the cup and see what happens. What do you think? Can you guess what would happen when I put the glove around the cup, and then I'm going to tip the bicarbonate of soda, which is in the glove, in the vinegar, which is in the cup, what do you think is going to happen? Any guesses? Pop it in the chat box if you have any guesses around that, and we will try it just in a minute. So remember, there was this chemical reaction where the bicarbonate of soda and vinegar mixed together and release a gas. So the chemical reaction released the gas carbon dioxide. So because the carbon dioxide now has nowhere to go, it gets trapped in the glove and it starts to inflate the glove. So now you can see an inflated glove because all the carbon dioxide is trapped in the glove. I can hear the fizz as well. So the reaction is definitely happening. So the bicarbonate and the vinegar mixes together to make the neutralization reaction. So you can repeat this experiment. Don't worry if you don't have a glove, you can do it with the balloon. So take a bottle, add some, any water bottle or a plastic bottle, add some vinegar to the bottle, add some bicarbonate to the glove, and then same way, tip it over, and then you will be able to see the balloon getting inflated. So you can do that as well if you don't have a glove. So pH is something which chemists definitely use when they are analyzing different chemicals, when they are looking at an unknown chemical which they haven't found yet. So they are trying to look at the properties. So pH is one of the main properties they look at when they are trying to find new chemicals. So they match it and then try to match with the database which they already have. So they do use pH or chemistry-based experiments to do some science. So the last activity which I have is with some cans. So I have a can here and I'm going to balance the can. Do you think I'll be able to balance the can in an angle? Would that be possible? Well, I think I have some magic powers and I'll be able to do that for sure. So what I'm going to do is I'm going to balance the can. So I need to concentrate for this. So I'll try to balance it so that you can see it. Cool. So do you think you can do that? Do you think I have superpowers? Well, no, this is science. So this is just a can, any empty can you can find. And what I've done is I've just filled some water in it. So I filled about this much water, not half, but less than half. So what you can do is you can balance a can with some water, but if you try to balance a can which is empty, you won't be able to do it. No, even I can't do it. So you can test that as well. So take a can and then pour some water in it, try to balance it. This is because of the science behind it is called center of gravity. So the center of gravity is a point where you can balance something. So just to give you an example, if you have a pencil, what do you think? Where would you balance the pencil? Somewhere in the middle, right? So if you want to balance a pencil on your finger, you will balance it somewhere on the midpoint of the pencil. But what about a hammer or a brush which has a heavier side? You have to balance it. You would take your finger more towards the heavier side, isn't it? So the center of gravity will move towards the heavier side. So this balancing point or the center of gravity is different for a hammer and for a pencil. So the same acts for the can with some water. So when you are trying to balance the can without the water, it's just somewhere, the center of gravity is somewhere in the middle, so it topples over, but with the can with some water in it, gets the center of gravity shifted slightly down, so you are able to balance the can. So I have a reply in the chat saying magnetic. So I'm afraid, no, I'm not using magnets. It's just empty can and water. So I'm sure you will be able to find an empty can and water for sure in your kitchen, and try to maybe trick your friends and family and see if you can show this trick, and then you can explain the science behind it. So center of gravity is the science behind this balancing can. So these are a few ideas which we wanted to share with you about different science investigations which you can do with your children or even your friends and family. But what else you can do to promote science? So I'll go back to my presentation. So we will look into how else can you engage your children with science, how you can promote that and make them enthusiastic about science. So use of simple language. So that's really very important. So if you are using complex language or terms, make sure you simplify them so that they can relate to it. So just like I said about indicator, so it's just breaking down and making them relate to like car indicators or something they can easily connect to. So use very simple language, make sure it is fun and interactive, so get them involved, get them to do some of this stuff, maybe when their friends are over for a play date or something they do together, give them some tasks to do, ask loads of questions. So questioning is another thing which you should always involve in your investigation. There are different types of questions, like open questions where you can talk a lot about it, thinking questions where they have to think and give the answers. Don't use closed questions like where you just have an answer like yes or no, or where there is just one answer, where there is no further discussion to follow up. So make sure you are asking open questions so they can answer, and then you can build up a discussion on that as well. So asking questions are just really very, very important. What about skills? Well, we always think when we talk about skills that the employers are looking for only skills which are knowledge-based or technical skills, but actually the type of skills they are looking for is like organizational skills. So even tidying up their room, making sure that their room is organized is kind of a skill. You are trying to promote that. Problem solving. So humans are by nature, they are problem solvers. So give them a task. So if you are giving them a task, give it as a challenge, give it as a problem, or post some questions around those tasks so they can come up with a solution for that. So problem solving is another skill. Also ITs, everyone is using computers, mobile, so that's something which is also important these days, to use different software. So do expose them to those different types of soft skills as well. Teamwork is really important as well. So if you have friends over, or if you want to do a science investigation as a family, work as a team, give different roles to each one so that they understand the ethos of teamwork as well. So these are the different employability skills which employers are looking for their candidates. So these are just not the knowledge-based skills, but also the soft skills. And also our curriculum for excellence in Scotland is based on skills. So it really helps us, or the kids to, the children, to promote skill-based learning. The other things which I would highly recommend to do is, if you are working in science or technology, engineering or maths, any of those fields, make sure you introduce your children about those as well, what sort of work you do, or if you know someone who's in science, do give them examples of how they do the science, what sort of things they do at work. Also, it's a good thing to just introduce them to the interests they have. So link their interests to science. For example, if they like playing video games, talk about the science which is behind developing those video games, programming, the graphics behind it. If they go out for swimming or any sort of sports, there is science behind it as well. Even what else? Yeah, any sort of sports they are interested in, or looking at cars. So if they are interested in cars, talk about the engine, talk about different components which are there in a car, how it works. So these kind of things, tiny little things, do include science in them. So these are everyday examples which we can easily tell to the children, and then ask them to relate how science work, and you will be able to see, or they will be able to also connect to how science is relevant in our everyday life. Praise and encouragement is one thing which is really important. So make sure you are always saying good words and encouraging them while they are doing the science investigation. So make sure you are praising. And as I said, we all have this image, or we all have this unconscious bias of who can do science and who can't do science. So it's just getting out there to see, to tell them that science is for everyone. So if you just observe things which are there related to science, you can really find science in everywhere. Even when you're cooking, obviously when you are mixing things together, our brain is subconsciously doing all that. We don't realize it. We are using maths when we are kind of baking different things, we are measuring different stuff. So when you're cooking or baking something, make sure you involve them as well. Talk to them why you're adding this much, or the ratios. So we are subconsciously doing all those things when we are cooking or baking. And chefs, they do come up with these different tasty recipes because they are trying different measurements or trying different recipes with different fruits and vegetables. So they are trying to work around that. So make sure you involve them when you're cooking, so they get to kind of learn about science and maths subconsciously as well. And apart from this, if you still want to promote or engage them with more science, there are science and discovery centres all around Scotland. So make sure, if you haven't visited one, just go to the nearest one which you find, and or maybe all of them. So go take them to the science centre. At the moment, because the science centers, all the science centers are currently closed. Most of the science centers are offering something digitally. So if you can, do go watch videos and stuff, the resources they are sharing on their website. So do go and watch that on their social media. So that's one thing which you can definitely do over this over the lockdown period. And even during the lockdown, I'm sure you will all agree that the medical facility, the research and industrial facilities have got so much input because they have this STEM background. They are able to offer so many different things, even this in this situation. So science or STEM is really very important. Even during these pandemic times, we won't be able to go online or do sessions like these if we didn't have the technology. So science is really important for us to be there, and we need young people to get engaged and do science as much as possible. And that's pretty much for me, I think. So if you do want to keep in touch, please feel free to drop us an email and go to our website. We are there on all different social platforms. So make sure, if you haven't liked or if you're not following it, please do go and follow us. We will be putting out quite a lot of digital resources throughout this month. So this Summer of STEM we are doing is all the digital resources are available on Facebook, on Twitter, Instagram. So do go and watch those activities, and I'm sure you will be able to try them with your friends and family as well. So thank you so much. If you have any questions, please feel free to drop them in the chat box. I'll try to answer them now. If there are, I'll go back to the chat and see if I can find. Yeah, so if you have any questions, feel free to pop them on the chat. or if you have any questions about our new center or anything, I'll try to reply to those questions as well. Oh, this webinar, so yeah, that's the previous question. Okay, so if that's everything, thank you so much everyone for joining us, and thanks for the National Forum of Parent Forum of Scotland for giving us this opportunity to be involved with these online webinars. We will be doing another session on Monday, which is more about forces, so using again simple everyday items which you can find. So thank you so much, and we hope to see you soon for the other sessions which we will be doing next week. So thanks and bye.